Hello everyone. Today I will introduce three key mathematical concepts and their application. The application of derivatives in economics, the Washer method for finding the volume of a solid of revolution, and the concepts of moments and center of mass. We will go through each of these topics in detail, explaining their significance and practical applications. First of all, let's delve into the application of derivatives in economics. One of the most important applications is in cost function. In economics, a cost function Cx represents the total cost incurred by a business to produce a certain number of goods, where x is the number of goods produced. When analyzing costs, it's crucial to understand the marginal cost. The marginal cost is the cost of producing one more unit of a good, which is essentially the derivative of the cost function. Now, let's take an example. Suppose the cost function is given by the slide, which is Cx equal to 100 plus 5x plus 0.02x squared. And in this equation, the 100 represents the fixed cost, the cost that do not depend on the quantity produced. And 5x represent the variable cost that increase linearly with the number of goods produced. And 0.02x squared represent a cost that increase at an accelerating rate as production increases. To find the marginal cost, we need to derivative the equation into equal to 5 plus 0.04x. And this will tell us that the cost of producing an additional unit increases with the number of units already produced. For example, if x equal to 10, the marginal cost will equal to 5 plus 0.04 times 10 and equal to 5.4. So at the production level of 10 units, it will produce one more unit would cost an additional $5.40. And you may ask, why is this important? Because the marginal cost help business to make a decision about whether increasing a production is worth it, depending on how much additional revenue it generates. If the marginal cost is higher than the price the company can sell the goods for, it might not be profitable to produce more. Next, we move to the average cost function. The average cost is the cost per unit of producing a good, and it is calculated by dividing the total cost by the number of units produced. The formula, as you guys can see, that is in front of a slide, which is ACX equal to CX divided by X. And using the previous slide example, if the equation Cx equal to 100 plus 5x plus 0.02x squared, we can find the average cost by using this function divided by x, and it will equal to 100 divided by x plus 5 plus 0.02x. And the average cost function gives us insight into how much it costs to produce each unit on average. At lower production level, average costs tend to be high because of the fixed cost. As production increases, average costs decrease until the company hit its most efficient production level. To find the minimum average cost, we can take the derivative of average cost function. This tells us where the cost per unit is at its lowest. For the given ACX function, you would differentiate it and set the derivative equal to 0 to solve for x. And this is critical for business because it tells them at which production level they are operating most effectively and balance between fixed and variable costs. Another important application of derivatives in economics is in revenue function. The revenue function represents the total income of a business earned from selling goods. If Px is the price per unit and X is the quantity sold, the revenue function will equal to, in front of the slide, Rx equal to Px times X. Let's consider a price function Px equal to 100 minus 2x, where the price decreases as the quantity sold increases. The revenue function will equal to 100 minus 2x times x, and it will equal to 100x minus 2x squared. To find the marginal revenue, which represents the change in revenue from selling one more unit, we take the derivative of the revenue function Rx equal to 100 minus 4x. If x equal to 10, the marginal revenue will equal to 100 minus 4 times 10, which is equal to $60. And when selling 10 units, the additional revenue will generate to $60. And understanding marginal revenue will help business to making pricing decision. For instance, if the marginal revenue is declining, it may indicate that the company should either reduce production or adjust the price to optimize the revenue. Finally, we have a profit function. A profit function is the revenue function minus the cost function, and it gives the total profit earned by a business at a given production level. The marginal profit is the derivative of profit function, which shows the rate of change of profit with respect to the number of goods produced. Analyzing marginal profit helps business maximize their profit by determining the optimal production level. Now let's turn our attention to the washer method, which is used to calculate the volume of a solid of revolution. The washer method is a variation of the disk method, where instead of a single disk, we consider a thin washer or ring formed between two curves. This is useful for finding volumes when the solid has a hole in the middle. Let's say we have a region bound by the curve function fx equal to x squared and function gx equal to x. And the region is bound between the x-axis between x equal to 1 and x equal to 3. The volume of the solid formed by rotating the region can be computed using the following formula. As you can see, the volume is equal to the pi times the integration of square of function x minus the square of function gx. And after the finish the calculation, by evaluating this, we can obtain the volume of the solid of the revolution. And finally, let's discuss the moment and the center of mass. These concepts are crucial in physics and engineering, as they help describe the distribution of mass and identify the balance point of an object. A moment refers to the distribution of mass relative to a point or axis. In terms of rigid body, the moment of a mass distribution about a point gives us an idea of how much force would be required to rotate that body about that point. Mathematically, the moment about a point A is given by the equation ma equals to the integration of x times function of px, where x is the distance from the point and px is the mass density function. The center of mass is the point where the mass of an object can be considered to be concentrated for the purpose of analyzing motion and balance. For a uniform object, the center of mass is typically at the geometric center. However, for a non-uniform object, we can calculate the center of mass as the weight average of each mass distribution. Suppose we have a thin uniform rod of length L. The center of mass of this rod is located at its midpoint, so the center of the mass at a distance of L divided two from either end. For a more complex object, such as a composite body made of different material, the center of the mass is found by taking into account the mass and position of each individual part. This can be done using the weight average formula. As you can see in the slide, is x equal to the sum of mi xi and divided by the sum of mi. And in this equation, the mi is the mass of each part, and the xi is the position of each part. And to summarize, today we have covered the application of the derivative in economics, including cost function, revenue function, and profit function. We also discussed the washer method, which is used to calculate the volume of solid of revolution, and we explore the concept of moments and center of mass. These mathematical tools are vital not just in economics, but in many fields such as physics, engineering, and optimization problems. By understanding this concept in more depth, we can make better decisions in business, design more efficient products, and solve real-world problems more effectively. And I think that's all for my presentation. And thanks for your attention.